Here's a video solution guide to the first quarter exam review. So beginning with the very first question, the symbol here means parallel. It means that these two lines are traveling in the same direction. So to signify that, I'll put two arrowheads here, and I'm already thinking about alternate interior angles as part of this question because of all the interior angles there. It says that angle EFG is 32. So E to F to G is talking about this angle here, that's worth 32. And without even reading what they want me to do, I know that this one here is also 32 because those are alternate interiors. And that's just me reacting to the question without even reading the question. So the very next part says AEG, angle AEG. So AEG, this angle here, is 137 degrees. It looks right. It looks bigger than 90 degrees. 137 it says. And they want me to find EGF. So they want me to find EGF. So this is the one they want me to find. So let me put an arc there as a reminder. So to get that one, I'm going to need to get, well, there's a few ways I can do this. Maybe the easiest way is just to find this angle here. Together, these two angles, what's the math word for that? The vocabulary word, those two angles are what kind of angles? Linear angles. So I know that this angle here in white would have to be 43 degrees to complete 180 degrees. And then I can use the fact that this triangle here adds up to 180 degrees. So if I got 43 and 32, so far I've got 75 so far. So that means that the last angle would have to be 105 degrees, because this is my total, 180 in a triangle. Subtracting away gives me 105 for this angle in blue. And it could have been done another way as well. The 43 up here is also 43 here. And I could have done it as these three angles together make 180 degrees as well, and I would have gotten the same answer. Anyway, so 105 is what they wanted. Next one. All right, again, we've got parallel lines, and I'll put the arrowheads in here. And again, just reacting to it, this angle has to be 43 degrees because these two angles are the alternate interiors. And they're telling me that that's 152 on the outside here of this triangle. So they're asking me for some true statements. Maybe I'll just go ahead and see how many of these angles I can find and then see which of these would be the true statement. So these two angles here are linear. So this missing angle has to be 28 to make 180 altogether. And since it's alternate interior angles being equal, this has to be 28 as well. I've got a missing angle here in blue that's the same size as this one here because those two angles are vertical. Oops. So to find that missing angle, I have to remember that a triangle has 180 degrees in it. And if I've got 43 and 28, so far I have 71 degrees so far. So that means that I'm going to need another 109 degrees to complete the triangle. And those are vertical, so that has to be 109 as well. And now I can start looking at the choices. Is angle D 28? No. Is angle A 43? Nope. Is angle ACD 71. Well, I don't see any 71s. ACD is talking about this angle here. ACD, well, that would be 71 because these two angles here are linear, or you could say these two angles are linear. So the rest of that 109 would be 71 to finish the 180. And that BC is BCE 109. Well, BCE is this angle here, and that's not 109. So it would be choice 3. All right. Question number 3. Parallelogram ABCD is shown below, and it says there's some bisectors. It says that the bisectors of ABC, angle ABC, and angle DCB meet at point E. So it says that the bisectors of the angles meet at point E. So these white lines are not bisecting a segment necessarily, they're bisecting angles. So it's saying that angle ABC, that's this one here, is getting split in half by that bisector. And it says that the other bisector is splitting DCB. So DCB is this one. So I know that that's being chopped into two equal pieces. Okay, it says angle A is 68 degrees. So let me zoom in here and place it. Now, in the reading it says that this is a parallelogram, so the opposite sides are parallel to each other. That could be very useful. And I can see that it's useful right here. They want me to find angle BEC. So this is the one that I want at the end. So apparently all those other angles are going to help me find the one that I want. So thinking back to some of our vocabulary, here's a set of angles that doesn't get talked about all too much. It's the consecutive angles. This angle here, this angle here are not equal to each other since the lines are parallel, but they are supplementary. They do add up to 180 degrees. So angle B, the entire angle, would have been worth 112 degrees to make 180. And that 112 is getting split up evenly by the bisector. So now I know that each of these is worth 56 degrees because it's getting split in half. And I can also tell by the picture that this angle here entirely is 68 as well, because these two angles here also must make 180 degrees because they are consecutive interior angles. So that 68 is going to get split up into 34 degrees apiece for here and here. And that's one way to get at this angle right here. So altogether, just looking at the triangle then on its own, okay, this triangle here has to add up to 180 degrees, and we've got 34 and 56 so far. So we've got 90 degrees so far. So the last angle that's missing has to be worth 90 degrees. Okay, question 6, we have a proof, and just jumping right into it. You've probably had a chance to read it, of course. We're trying to prove that angle T is equal to angle I. And we're starting off with two givens, and I'll mark them down too. It's an isosceles triangle. Well, I can mark that down as two sides being equal. It says the vertex angle is TRI, which means the very top of the angle or the triangle is the vertex. It means this is the base and these are the base angles. So these must be equal sides. And it says that RA is an angle bisector of TRI. So TRI is getting split in half. So this half here is the same as this half here. So I can already see this is coming together. I'm going to have to prove that these two triangles are congruent. And I've already got two of the missing parts that I need. I know that TR is equal to IR because an isosceles triangle has two equal sides. So that's one fact that matches both triangles. Now we need two more. We've got the angles that are equal at the top. Angle TRA is the same size as angle and shape as angle IRA. And that reason would be bisectors make two equal angles, or simply bisectors cut in half. And remember something that's I've been trying to emphasize, that if you see a word on the left-hand side, it will usually show up later on the right-hand side. And there, it works with the isosceles. It says something about an angle bisector here. And look how I'm writing about the angle bisector here. We're down to just a couple more steps to finish. And the missing piece, of course, would be that RA is equal to itself. And that would be the reflexive property. And that completes a side angle side pattern that's happening. So now I know that the triangle TRA is the same size and shape as triangle IRA. And the pattern is a side angle side. Now that I know that's true, every part that's on one triangle must have a matching part in the other. That reason is called CPCTC. All right, there was another question on here, question 6B. And there's a bit of a misprint there. It should say angle T here instead. So looking back at the picture, I'll redraw it because it is getting a little bit messy there. So angle TRI is worth 70 degrees. And they want to know how big angle T is worth. So in an isosceles triangle, the base angles are the same size. So if this vertex angle is 70 degrees, it leaves 110 degrees left over that have to be split evenly between both of those two angles there. So each of these angles, T and I, would both be worth 55 apiece. Okay, on to the last question on this page, question 7. So it's another proof with the statements and the reasons. So I wrote down the givens, and now I'll mark it in the picture that says that TR and UV bisect each other. So these segments are the same, these segments are the same. I'm trying to prove that TU and VR are parallel to each other. So I have to plan this out before I begin. If I want to prove that these two sides are parallel to each other, I can do that easily by getting these angles equal to each other. So if I knew that those angles that I'm pointing at are equal, then I know the alternate interior angles are equal. So then I could say that those blue segments are parallel to each other. Now in order to get this angle equal to this angle, I'm going to have to prove that the triangles are identical, and I'm basically there. I mean, you can see by now that this thing is going to be a side angle side. First of all, I could use the bisectors to tell me that TW is the same as RW. And I could also say that UV, just like the picture shows, that UW is the same as VW. And what you could write is bisectors cut in half, or bisectors make equal segments. If you notice that sometimes we have an angle bisector and sometimes we have a segment bisector, and these are segment bisectors, segments cutting segments. Then the vertical angles appear. So angle U, the angles in white are the same. So angle UWT is exactly the same shape and size as the angle VWR. That's because vertical angles are equal. All right, now we've got enough information with 3 matching parts to say that triangle UWT is congruent to triangle VWR, and that would be because of side angle side. And then we're just 2 small steps away from finishing the proof. That's the hard part, is getting the triangles congruent. Now the rest is smooth sailing, because we can use CPCTC to declare that any parts in one triangle are exactly the same as parts in another. So I can prove that these black angles are congruent from the simple idea that if the triangles are twins, then every part in one triangle must be equal to a part in the other. So that's CPCTC. So the black angle UTW is the same as angle VRW, the black angles. And now that I know that those are equal, I could say that for sure that TU is parallel to VR. And that's because if alternate interior angles are equal, then we know we have parallel sides. Okay, done. And so here's a walk on how to find a median of a triangle and how to construct it by using a compass. So I'll flip through these slides really quickly. I just took these off my whiteboard. So if I want to find the midpoint here on this side so that I could draw the median in, that's an example of what I'd want to see happen. But to draw it officially or construct it officially, I'll need the compass for it. So to locate a midpoint, you make a perpendicular bisector. So looking at the next slide right here, to begin making the perpendicular bisector, first I swing from point A, then swing from point B, draw in the perpendicular bisector, and that locates the midpoint, and then all you have to do is connect the opposite vertex to the midpoint, and that is your median. And that's the answer. So you'll see one like that on the review sheet, and you'll also see one like that on the test probably. And I think there's just one more proof left. So this is one from September. Prove the vertical angle theorem by proving that angle AED is equal to CEB. So I want to prove that AEB is equal to CEB. And if you remember how that goes, we use linear angles twice. So I could begin by saying that angle AED plus angle AEC makes 180 degrees. I could also say that these two angles make 180 degrees as well. So angle AEC plus angle CEB makes 180 degrees. And the reasons for both of those would be that linear angles make 180 degrees. So let's talk about why these were smart choices. Well, it was a smart choice to start talking about AED because it's one of the angles that I'm trying to prove equal. It was a smart choice in the second line to use CEB because that's also an angle that I need to find in the question or in the proof. And these pieces here match, and that is the part of the rainbows or part of the linear angles that overlap. So you can see that this overlap right here is needed so that when I put these together as one statement, and this is where it gets a little crammed, I can take both of those statements, and since they both equal 180 degrees, I can replace the 180 degrees with AEC plus CEB. There's another video probably on the same channel that goes over this. That is substitution. And now we just want to subtract away the part that is repeated so the AEC can disappear on both sides, and that gets you to the very end. Angle AED is congruent to angle CEB. Well, I hope this helps. Please study, and if there's after-school tutoring, I'm sure I'll let you know about it, and watch the video again if you really need to sort of soak up these ideas. Good luck studying, and just keep on putting your best foot forward.